Hi everybody. So today we're going to do section 8.2 of your guided notes. So you're going to follow along with your notes with me and then fill it out as we go. And then when we're done, you're going to work on some practice problems on your own. So make sure you're getting this all written down so you have something to refer back to if you need. All right, so we talked about volume of a cylinder in our last lesson. And so today we're going to look at how do I find the volume of a cone. And you'll see here that a cone looks kind of like a cylinder, but instead of having two circular bases, it now has one circular base, and the other side kind of comes to a point. Okay, so you kind of think of like your ice cream cone, right? So our volume of a cone is found by using our formula that you see here. Volume equals 1/3 pi times the radius squared times the height. Now I do want to show you a short video clip that explains the difference between the volume of a cylinder, like we were doing last time, and the volume of a cone, like we're going to look at today.
Hello. In this video, I'm going to be comparing the volume of cylinders and the volume of cones. And to do that, I've constructed some little examples that I will show to you. In this one right here, I have this cylinder filled with popcorn kernels, and it's clear, so it's difficult to see, but I have a cone right next to it. And I tried to make this so the height of the cone is exactly the same as the height of the cylinder. And I also tried to make it so the size of this circle on the top of the cone is the exact same size of the circle here on the cylinder. So the first question I have is, which one is bigger? Which one holds more volume? And so to do that, we are going to begin by pouring the popcorn kernels from the cylinder into the cone to see if we can completely fill the cone. So let's go ahead and begin filling that and see what we get. And it looks like now we have completely filled the cone, and there is a lot of popcorn left in the cylinder. So it's not a surprise then that the cylinder has a greater volume than the cone. And remember, this is true when the circle is the same size as the circle on the cylinder, and the height of the cone is the same as the height of the cylinder. Next, we've got this one filled up, but the next question is, well, how much bigger is the volume of the cylinder than the volume of the cone? And we can keep this cone right over here, but let's bring in a second cone, and let's start to fill this one. Alright, it looks like now we have completely filled a second cone, and there is still popcorn left in the cylinder. Let's bring over a third cone. Let's fill up this one. And we have now filled the third cone. Let's bring all those cones over here next to the cylinder. We have filled up 3 cones, and now the cylinder is completely empty. So it's kind of interesting to me, kind of a coincidence, that the volume of this cylinder will fill exactly 3 cones, not 2.5, not 4.5, not 5.5. Exactly 3 cones can be filled from that one cylinder. So now the next question is, what are we going to do about our formula?
Okay, so we watched the video and we saw that it took 3 cones of the same height and radius to fill one cylinder. So we could say that a cone is 1/3 the volume of a cylinder with the same dimensions. So everything we do today is pretty much the exact same thing we did when we were finding the volume of a cylinder. The only difference is a cone is 1/3 that volume, so then we just add in this 1/3. So we're essentially finding the volume of a cylinder and multiplying it by 1/3 because we know a cone is 1/3 the volume of a cylinder. Everything else is the same thing we were doing last time. So let's practice a few of these. So we've got a cone here. We can see that has a radius of 4 and a height of 10. So let's plug these numbers into the formula as we see it here. So I'm going to say volume equals 1/3 times pi. We're going to use 3.14 for our pi, just like last time, times the radius. Radius is the measure halfway across the circle. So radius is 4 squared, times the height, which is 10. So then we just go to our calculator. So I'm going to come over here to my Desmos calculator, and I'm going to type that in. So we had 1/3 times 3.14. So I'm going to type the fraction, 1/3 times 3.14 times my radius, which was 4 squared, times the height, which I believe was 10. Yes. So we just type that in the calculator, 1/3 pi r squared times the height, and we get our answer. Now we're going to practice rounding to the nearest hundredth, so that's 2 places after the decimal. Here, that gives me 167.46. The number after the 6 is 5 or above, which tells me to round up, so I'm going to bump that up, so 167.47. So we'll come over here and say the volume of this cone was 167.47. And then our unit here is meters. And since we're dealing with volume, it's always cubic meters, so we say meters cubed. So 167.47 meters cubed. Okay. So I want you guys to try the next two. So I'm going to have whoever's playing the video pause it and give you guys a couple minutes to try the second 2 examples in your notes. Use your Desmos calculator on your computer and set that up. See if you can calculate the volume, and then we'll check it here in a minute. All right, so now that you've had a chance to try them on your own, let's see how you did. For the second example, we should have 1/3 times 3.14 times 2 squared times 7, which when typed in the calculator gives us 29.31. And if you want to see what that looks like in the calculator, that's this example right here. 1/3 times 3.14 times 2 squared times 7. Then for the second one, we had a radius of 6 and a height of 7. So we do 3.14 times 6 squared times 7. And we get 263.76. Now, sometimes they won't actually give you the picture of the cone, and that throws people off. So let's look at an example where we just have the dimensions without the image. So it says in the first example here that a container is shaped like a cone and contains oil. The radius is 5 feet and the height is 7. If it helps you to sketch a picture to visualize it, you can do that. You can draw a little cone and label that the radius is 5 feet and that the height is 7. If that helps you plug it into the formula, you're welcome to do that. We otherwise just know the radius goes in for R and the height goes in for H, and we plug it into our formula. Volume equals, since it's a cone, we do the 1/3 times pi times the radius, which it tells us is 5 squared, times the height, which is 7. So we just plug in height for H and radius in for R. And then we just go back to our calculator and plug it in. So I'm going to go back to Desmos here and do my 1/3 times the 3.14 times the radius, which was 5, and the height, which was 7. So 5 squared, and then times the height, 7. So we type that all in, we get our answer. The volume is 183.16, but again, the 6 after that bumps it up. So 183.17. So we'll fill that in, 183.17 cubic feet for our volume. All right, the next one, dimensions now have some decimals in them. Sometimes that throws people off, but it's still the same thing, and we have a calculator to help us, so no need to panic, right? We just plug it in to the formula. So volume equals 1/3 times pi 3.14 times the radius. It tells me here that the radius of the water level is 0.5 yards, so 0.5. So I'm going to say 0.5 squared times the height, which it tells me the depth of the water, how deep it is, that's the height, 1.5 yards. So same thing, we just go to our calculator and plug that in. So I'm going to do my 1/3 times my 3.14 times my radius, which was 0.5 squared, times the height, which was 1.5. Okay, and then that gives us our answer of 0.39 if we round to the nearest hundredth. So we'll just say this has a volume of 0.39 meter or yards, not meters. Let's change that to yards cubed. All right, let's look at the next example. Next example says a basketball coach is trying to decide if he wants to buy cone-shaped cups or regular Dixie cups for water drain games. A cone-shaped cup has a radius of 2 inches and a height of 4 inches. A Dixie cup has a diameter of 3 inches and a height of 3 inches. Which cup should the coach purchase and why? So we want to figure out which cup holds more water, right? Where are we going to get better value? So let's start by finding the volume of the cone. What's the volume of a cone? So we do volume equals of the cone cup. Since it's a cone, we do 1/3 times pi 3.14 times the radius of the cone-shaped cup, which was 2 squared, times the height, which is 4. So let's type that into our calculator here and see what we get. So I'm going to do my 1/3 times 3.14 times the radius, 2 squared, times the height, 4. And so that gives us 16.7, if we round to the nearest hundredth, 75. So we'll fill that in and say the volume of this cone is about 16.75 inches cubed. Okay. Now we have a cylindrical cup, right? Your traditional Dixie cup. So if it's a cylinder, it's the same formula without the 1/3, right? A cone is 1/3 the volume of a cylinder with the same dimension. So just like we did in the last lesson, we just do pi. We don't need the 1/3 for a cylinder, times the radius, which it says the diameter is 3, so be careful. If diameter is 3, radius is half of that. So the radius would be half of 3, which is 1.5 or 1.5. So pi times radius squared times the height, which is 3. So we plug that into our calculator. All right, so I've got pi 3.14 times the radius, 1.5 squared, times the height, 3. And that gives us 21.195. Nearest hundredth would be about 2.20. So volume equals about, what was that? About 21.20 inches cubed. So we can compare the difference between the two. this 16.75 is much smaller than this 21.2. So where's the better value here? We're going to be able to hold a little bit more water in the traditional Dixie cups as opposed to the cone-shaped cups. So we would recommend that the basketball coach probably buy the the cylindrical shaped Dixie cups, not the cone-shaped cups, because they don't hold as much. Okay, so now if you remember in the last lesson, we did also use the volume formula to calculate the height of a cylinder from the given volume. We're going to do the same thing today, but with a cone. So if I told you the volume of the cone, and I told you the radius, and asked you to find the height, we're going to do the same thing as last time. We're going to plug in everything we know into the formula and use that to help us solve for what we don't know. So here we know the volume is 6,672. So I'm going to put that into my equation for V. So I say volume equals, it's a cone, so we do the 1/3 times pi, 3.14, times the radius, halfway across the circle, 7 squared, and we don't know the height, so I just say times h. Okay, we're solving for h, so think of it as an algebraic equation. We want to get h by itself. First thing I'm going to do is simplify everything over here that I can, right? I can go ahead in my calculator and do the 1/3 times 3.14 times 7 squared. So if I go to my calculator, I'm going to do 1/3 times 3.14 times the 7 squared. Oh, goodness. Make sure we click out of the fraction. Times 3.14 times 7 squared. And that gives me 51.2. That'll round up to 29. So let's say 51.29. Okay. So we just multiplied all of that together and got 51.29 in our calculator. So now I have 51.29 times the height equals this 6,672. Now to get h by itself, we just need to cancel the multiplication, right? So we do the opposite. The opposite of multiplying by 51.29 would be to divide by 51.29. So I'm going to divide both sides by 51.29. And so my last step is to go to the calculator and do that. Was it 6672? Yes, divided by 59.29. And that gives us 112.53. So I'm going to say my answer here is 112.53. So now I know the height of this cone is 112.53 inches. All right, we're going to look at another one together. In case that was a little confusing, we'll walk through another example. So this time I have a cone with a volume of 2,100. So we put that in for the volume. We say 2,100 equals 1/3 times pi, the 3.14, times the radius, 7 squared, times we don't know the height, so we just put h. We're solving for the height. So that's where we come over here and we can simplify everything on this side of the equation. We can do the 1/3 times 3.14 times 7 squared. So we're going to type that in our calculator. All right, so we have the 1/3 times 3.14, and then what was our diameter? 7. So times 7 squared, and that gives us 51.29. All right, so we say we've got 51.29 when we multiplied all that together, times the height equals our volume, 21,000. Last step then to get h by itself is cancel the multiplication with division. So we divide both sides by the 51.29. So when I do 2,100 divided by 51.29, let's see what we get. All right, divided by the 51.29. And we get about 40.94. So we'll say 40.94 equals my h. So now the missing height of this cone is 40.29 meters cubed. I've got 2 examples left in your notes. I'd like for you to try those on your own, and then we'll check them together. So I'm going to have whoever's playing the video pause it and give you guys a few minutes to work those out for the height. And then when they look ready, go ahead and push play again, and we'll check our answers. Okay, so if we check the next one, we plug in the volume, 1,950, along with the radius, and we're solving for h. So we go ahead and simplify the 1/3 times pi times 4 squared and get 16.75. So our last step is to divide both sides by 16.75, which should give you about 116.42 meters for the height of this cone. Okay, I'll leave that up for a sec so you can kind of check it over before I go on. And our last one, we have our volume. We plug it in for V equals 1/3 times pi times the radius 11 times the height's what we're solving for. So we multiply everything we know over here, which simplifies to 126.65. So then we cancel multiplication with division. So I divide both sides by the 126.65. And that gives us about 69.98. So the height of our cylinder here is 69.98 centimeters when rounded to the nearest hundredth. Now, before you guys go to practice on your own, one thing I want you to be extra cautious of is sometimes you're given the diameter, not the radius. So pay close attention to that. Biggest mistake people make is plugging the diameter into the formula when we know diameter is all the way across and we want the radius halfway across. So if they do give you the line all the way across, if they give you the diameter, divide it by 2, cut it in half, and plug the radius into the formula. So just be extra careful of that so you don't miss those questions and avoid those mistakes. And you've got the rest of the time to practice. You're going to get a worksheet and just go over the same thing we did here in the notes. And then you'll practice a little bit more for your next remote assignment. And I look forward to seeing you guys when I am back on Friday.